So good afternoon all. In the previous lecture, we have seen transportation problems, unbalanced, balance, then three methods for getting initial basic feasible solution, northwest corner least cost method and Vogel's approximation method. After that, for optimality check and to do further optimization, we have seen two methods. Uh, the first one was stepping stone method and second one UV or modified distribution method or MODI method. So in today's class, we are going to see the last case of transportation model or transportation problem, that is transportation problem with degeneracy. Up till now, we have seen only non-degenerate generate problem. So let's begin with this example. Here, our aim is to find out how much delivery or how much amount of component to be transferred from each factory to each store, such that the transportation cost should be minimized. Now, if you look at this problem statement, you will find that this problem statement is having unbalanced supply versus demand. Also, after few minutes, you will get that here you are going to face a degenerate initial basic feasible solution, and we are going to again have a quick revision of how to implement UV or modified distribution method, because compared to stepping stone method, UV or MODI method is faster. Okay, so let's begin this solution. If you sum up the supplies, so see 40 plus 40, 80, 80 plus 50, 130, 130 plus 90, it becomes 220. So the supply is 220. Now sum up the demand part, 90 plus 30, 120, 120 plus 50, 170, 170 plus 30, so your demand is 200. So that means in this problem, supply is not equal to demand. That's why it is called as a unbalanced transportation problem. Now, how to resolve this issue? Simply just add a dummy. Okay, if supply is greater than demand, supply is greater than demand, add dummy column. That means create a dummy demand. आप क्या करोगे? एक dummy demand prepare करोगे. If demand is greater than supply, then you will add a row here, because now the demand is large, we don't have that much supply, so we will create a dummy supply. जितना डिफरेंस रहेगा सप्लाई एंड डिमांड का, उतना डिफरेंस का डमी सप्लाई प्रिपेयर करेंगे और वी विल प्रिपेयर डिमांड. So based on which is more, prepare either add dummy column or dummy row. So here supply is greater than demand, so we need to create a demand of 20 units. That is your dummy demand. Okay, so demand is in the column, so we will add a dummy demand of 20 components. Let's add that. So हमने एक dummy demand का column add कर दिया, which is asking for 20 units. Now, as this is a dummy one, that means from a factory to a dummy store, we are going to transport some amount of component whose transportation cost will be zero, because it's a dummy one. तो उसका transportation cost हमने zero assign किया. Okay. Now we will solve this numerical using Vogel's approximation method. So let's get the initial basic feasible solution by Vogel's approximation method. Okay. Now for Vogel's approximation method, now the student who don't understood the Vogel's approximation, I'll repeat this procedure. Otherwise, remaining student, they can attempt the solution for this numerical. Take the screenshot, prepare a table on your notebook and try to solve this. using Vogel's approximation method. Get the initial basic feasible solution. After 1 minute, I'll start my explanation regarding Vogel's approximation method. Okay, the student who knows VAM method, they should attempt up to the initial basic feasible solution. The student who don't understood the Vogel's approximation method, let me show you the procedure again. Now, select the row number 1. Check out the smallest and second smallest number. So here, smallest number is 0, second smallest number is 1. So write the penalty in front of that row equal to the difference between smallest and second smallest number. So here 0 and 1, so penalty is 1. Apply the same concept for row number 2. The smallest number is 0, second smallest number is 3, so here penalty is 3. In next row, smallest number is 0, another second smallest number is also 0, so penalty will be 0. Or you can put dash. In the fourth row, the smallest number is 0, second smallest number is 1, so the penalty will be 1. Apply the similar approach for columns. Column number 1, smallest number is 7, second smallest number is 6. So smallest number is 6, second smallest number is 7, so the difference is 1. So penalty will be 1. In column number 2, the smallest number is 1, second smallest number is also 1, so the difference is 0. Third column, smallest number 0, second smallest number 9, so the penalty will be 9 here. In fourth column, smallest number is 1, second smallest number is 3, so the penalty will be 2. Here in the dummy column, all the values are 0, so you can put difference as dash or 0. Okay, so this is your penalty calculation. Select a row or the column having maximum penalty. So here the 9 is the maximum penalty, so we'll choose that that column. So this is your chosen column with the maximum penalty. Find out the least cost here. कहीं पे allocation करना है तो कहाँ पे करोगे आप? जहाँ पे zero cost है या फिर 12 rupees transportation cost होगा. Our aim is to minimize the transportation cost, so you are gonna select the least cost here. So 0 पे allocation करेंगे. कितना allocation कर सकते? The C is supplying 50 and shop number 3 is asking for 50. So yes, we can satisfy the complete demand here by allocating 50 number here. Okay, so let's clear this out. So this way you can do the allocation. Now the demand is satisfied and also the factory C is exhausted. पूरा का पूरा components supply कर दिया उसने. Okay, now again do the calculation for penalties for each row and each column. Again repeat the process. So erase the previous one. I'll scratch this out. So take the difference of 0 and 1 here. So sorry, it will be 1. Next row 0 and 3, so the penalty will be 3. Row number D, 0 and 1, penalty will be 1. Okay, go for columns 6 and 7, so penalty 1. 4 and 1, so that will be 3 here. Next one 1 and 2, so penalty will be 2, dummy may 0. So you will find here in this case there are two places where the penalty is same, 3 and 3. Okay, so choose any one of them, but when you choose it, try to go for the least cost. Now if I choose this row number B, the least cost is 0 here. If I went ahead and chosen the column, the least cost is 1. Okay, so that means we have two opportunities. Either we can go with 1 or 0, but always go with the least cost. सबसे कम कौन सा है 0. So provide the allocation at 0 here. कितना allocation कर सकते हैं 20 or 40. So 20, the least allocation. Okay, so this way you can do the allocation, proceed with the next calculation, and finally your result will be like this. Okay, so check this out, do the next calculation, and up to this part, initial basic feasible solution, please verify your solution, your answer, your allocation with the presented the allocation on your slide. Is it okay? If you are facing any doubt, let me know. Part. Now the next calculation. So up to this step, we call this step as a initial basic feasible solution, and the transportation cost for initial basic feasible solution, if you do the calculation, it will be 700 rupees. So how to calculate this? Total transportation cost will be equal to 6 into 30 plus 1 into 10 plus 3 into 20 plus 0 into 20 plus 0 into 50 plus 7 into 60 plus 1 into 30. So unit transportation cost into number of allocation, that's the way you calculate transportation cost. Now this cost arrives, it is equal to 700 rupees. Now we need to go for optimization, but before optimization we can only implement optimization procedure if we are dealing with non-degenerate initial basic feasible solution. Okay, don't worry about the complicated terms or pronunciation. Actually it is very easy. See, as per our definition, m plus n minus 1, just do the calculation for this. M plus n minus 1, m is number of rows, n is number of column. So in our problem statement we are dealing with 4 number of rows, so m is equal to 4 plus n number of column, so 1 2 3 4, and dummy, that is fifth, so we are dealing with 5 columns, minus 1, so 9 minus 1, that is 8. So what this degeneracy or non-degeneracy case suggests is that number of allocations should be equal to this m plus n minus 1. So in this problem, if we are allocating 8 cells with some resources, that means we are dealing with a non-degenerate case, or we can simply proceed with the optimization part. If somehow the number of allocations are less than 8, that means we are dealing with case of degeneracy. ओके अगर डीजनरेट होगा तो आगे वाला जो प्रोसीजर है, स्टेपिंग स्टोन हो या फिर आपका यूवी मेथड हो, इट विल नॉट वर्क. वी हैव सीन स्टेपिंग स्टोन में लूप बनाना पड़ता था. सो इफ आवर प्रॉब्लम इनिशियल बेसिक फिजिबल सॉल्यूशन इज अ डीजनरेट, मतलब नंबर ऑफ अलोकेशन कम है, तब क्या होगा, आप जो जंप मारते थे ना, जंप मार के टर्न वगैरह लेना, यू विल फाइंड कि भाई in most of the cases you will not be able to create that kind of loops. You will not be able to implement stepping stone method, or even for UV method, if number of allocations are less, that means you will not be able to calculate the U and various V values. So that's why it is important to have non degeneracy in our case. So in the current solution, just count the number of allocation: 1, 2, 3, 4, 5, 6, 7. So m plus n minus 1 is equal to 8, but the number of allocations here are 7. So that means the number of allocations are less than the expected 8 number. So our problem here is of a it is of a degeneracy. There will be degenerate solution. Allocation कम है अपने पास, so we will not be able to create a stepping stone or closed loops, as well as we will not be able to calculate all the values of u and v. ठीक है. अब आपको लगेगा कि it will be difficult to how to solve the problem further. It's very easy. देखो, जब भी सप्लाई और डिमांड का प्रॉब्लम आता था, हमने क्या किया, एक डमी लगा दिया just to balance it out. Here also there is a difference of 1. So whenever you face a problem with degeneracy, हम क्या करते हैं, एक डमी allocation करते हैं, which is having equal resources or number of components equal to epsilon. Epsilon is kind of a value. Epsilon is a term whose value is almost equal to 0. But instead of putting it as a 0, we call it as a epsilon, जिसका कुछ मीनिंग नहीं, इट्स अ डमी थिंग. Just this dummy allocation will help us for the further calculation for optimization purpose. Okay, now where should we allocate this epsilon? Epsilon should be allocated at the minimum cost, or at the location with the cost equal to or having least cost. And also it should be a independent cell. Independent cell means a cell from which there will not be we will not be able to create a closed path or closed loop. Okay, so first we will tackle the first part, minimum cost. Here, see, number of allocation should be 8, currently they are 7. So what we are going to do, we are going to add a dummy allocation which is equal to epsilon, and which is nothing but equal to 0 value only. Okay, now कहाँ पे एक बैलेंस करने के लिए हम ये एक सेल पे ऐड करने वाले, कहाँ पे ऐड करना है, मिनिमम कॉस्ट में. Okay, so look into your transportation matrix and get the unallocated cell with the least cost. Okay, unallocated cell देखो यहाँ पे 4 है, 6 है, then 1, 6, 14, 9, 11, 7, but all are more than 0, right? So we should allocate epsilon at least cost 0 पे. फिर भी यहाँ पे 3 ऑप्शन है, ऑप्शन नंबर 1, 2 and 3. Where should we add that epsilon? Where should we add that epsilon? So first criteria was minimum cost. Yes, minimum cost देखा हमने, but there is a tie in for of 3 locations. Now we are going to add epsilon for in the independent cell. Okay, let me introduce about independent cell. पहले देखो यहाँ पे ये वाला cell. If I do allocation here, is this cell independent? Independent cell means जहां पे close loop फॉर्म नहीं होता. Okay, but see here close loop फॉर्म हो रहा है देखो. So that means this location is not independent cell or independent location. Check out the next one. If I select this location, the corner point, okay, let me check, is this independent cell? देखो jump मार सकते हैं यहाँ से. I can create a loop like this. And I can come back here. So this cell is also not the independent one. Let's check out the third option here. Now for this cell, if you try to prepare a closed loop, it will be impossible. Okay, so let's try this. यहाँ से ऐसे jump मारा. Okay, so no option. Next another try करते, इधर से इधर jump मारते, then you will not be able to create another loop. Okay, so हमने दोनों option check किए. Either if we jump on this side, we are not able to connect it back. Also, if we jump onto this side, we are not able to create any kind of loop. So this location is the independent location. This cell is independent cell. So assign epsilon at this location, so that when we go for unallocated cell, this cell is going to help you to jump and turn, create a loop. So that's why I go for independent cell. That's it. This is the only concept that has to be highlighted in today's lecture. क्योंकि बाकी का part already हमने देखा है, WAM method देखा है, also the UV method is we have seen in the previous lecture. Only thing we haven't seen was the degenerate case, less number of allocation. ठीक है? So I hope all of you have understood degeneracy case कैसे handle करोगे आप. If you have doubt, let me know. Now just count the number of allocation: 1, 2, 3, 4, 5, 6, 7 and 8. Now it's a non-degenerate solution. Now next step will be optimization. Okay. So if there is no doubt in a degeneracy case, we will proceed with optimization. Let's go for optimality check by using UV method or modified distribution method. Quickly I will cover the method. So again we will prepare the same table, but now along with various values of u1, u2, u3, u4. Then v1, each column के लिए एक v लगा दो, v1, v2, v3, v4 and v5. So that's why it is called as a UV method. Okay, Gaurav, which part should I repeat?
Degeneracy, sir.
Okay, degeneracy. So quickly I'll have a recap on degeneracy. So see, by using Vogel's approximation method, you got the initial basic feasible solution. This is your initial basic feasible solution. Okay, then you calculate the total transportation cost. It happens to be 700. Okay, now the next step is optimization. So that means you are going to implement UV method or you are going to use stepping stone method. So before that, before implementing optimization method, we need to check how many number of allocations we have done, we have in the initial basic feasible solution. They should be, number of allocations should be m plus n minus 1. Then and then we will be able to implement UV method or stepping stone method. Okay, m is number of rows, n is number of column. So number of allocation should be equal to, see, number of rows are 4, number of columns are 5 minus 1, that is 8. If we have 8 number of allocations, then and then we can implement optimization process. But if you count number of allocations in the present initial basic feasible solution, they are equal to 7. मतलब अपने पास कम allocation है. जब भी आप number of allocations are less than m plus n minus 1, मतलब कम allocation होंगे, we call that case as a degenerate case, degeneracy or degenerate case. ओके okay? मतलब यहाँ पे कम ज्यादा है. सो कैसे सॉल्व करेंगे? सिंपल स्टेप है, इनको बैलेंस करेंगे. नंबर ऑफ अलोकेशन शुड बी इक्वल टू m प्लस n माइनस 1. अपने पास एक शॉर्ट है, देखो एक अलोकेशन कम है. सो बिफोर इंप्लीमेंटिंग ऑप्टिमाइजेशन मेथड वी विल सॉर्ट दैट इशू. जो कम अलोकेशन है वो ऐड कर देते हैं यहाँ पे. ओके, सो वी आर गोइंग टू ऐड ए अलोकेशन कॉल्ड एज ए डमी और एप्सिलॉन. ये अलोकेशन ऐड करना है. उसका वैल्यू इज अप्रोक्सीमेटली इक्वल टू 0. कि नंबर ऑफ कंपोनेंट ट्रांसफर्ड बाय दिस अलोकेशन इज आर इक्वल टू 0 ओनली. ठीक है, अब ये कहां पे करेंगे? अपने पास 7 अलोकेशन है, एक ऐड करने वाले, बट कहां पे करेंगे? सो फर्स्ट क्राइटेरिया, द फर्स्ट क्राइटेरिया इज यू शुड ऐड दिस इप्सिलॉन अलोकेशन at minimum cost. Minimum cost. Okay, so quickly go through your matrix, transportation matrix. Look for the minimum cost. Okay, तो यहाँ पे 3 minimum cost है, 0, 0 and 0, जहाँ पे आप allocation कर सकते हो. Because this 0 has already have allocation, this 0 is also having allocation. So we have only 3 options. Option number 1, option number 2 and option number 3. Now second criteria is going to help us to do the proper allocation, because we are in dilemma कि भाई कहाँ पे करेंगे. Okay, so second criteria says that do the allocation, if there is a tie, do the allocation at independent cell. Independent cell मतलब जहां से close loop form नहीं होता. Do the allocation for that cell, a cell without a closed loop, without a closed loop. Okay, so look into this matter. So option number 1, we will check this out. Option number 1, इज दिस अ इंडिपेंडेंट सेल. कैसे चेक करेंगे? देखो वो अपना स्टेपिंग स्टोन जैसा वो लूप बनाते थे ना. ट्राई दिस. सो अगर मैं यहां से चालू करूं, आई जंप ऑन टू दिस सेल बिकॉज इट इज अलोकेटेड. देन एज सुन एज यू जंप, आई टोल्ड यू द रूल ऑफ दिस स्टेपिंग स्टोन. जैसे आप अलोकेटेड सेल पे जंप करोगे, इधर यू हैव टू मूव टू राइट और लेफ्ट. यू नीड टू टर्न. ओके, टर्न करेंगे ऑन दिस साइड, टर्न करेंगे, फिर जंप करेंगे ओनली ऑन द अलोकेटेड सेल. सो वी विल जंप इट हियर, जंप ऑन दिस सेल. नाउ जैसे ही जंप मारा आपने, टर्न करना है. इफ यू टर्न ऑन दिस साइड देयर इज नो प्लेस टू जंप, so that means we need to turn on to the right hand side. Okay, so jump mara on the allocated cell, then again you can turn and come back. Okay, so this means first option is not independent cell because यहाँ पे closed loop form हो रहा है. ठीक है, so this option is you can cancel. Next option, I'll directly go to the third option. We will check is this a independent cell. यहाँ से jumping start करते हैं, वो game चालू करते हैं. We will jump on to this cell, then turn, jump. जैसे jump करोगे turn, jump, then turn either on to the this side, left side, so right side or left side. But देखो right side में कुछ available नहीं है allocation. So go to the left hand side. Now jump करेंगे on to allocated cell. I have already explained this procedure, but we will go in this process. ऐसे jump करेंगे and then again I can jump back to the original position. जहां से start किया था वहां पे jump back कर सकते. So even in this case also you will find that this is not the independent cell. This is not the independent cell because यहाँ पे भी closed loop form हो रहा है. Okay, so skip this. Now check out the last option. ये वाला सेल। अब देखो यहाँ पे आप अगर लूप बनाना चालू करोगे, यू विल नॉट बी एबल टू क्रिएट अ क्लोज लूप। ठीक है, चलो ट्राई करके देखते। पहले देखो, वी कैन जंप ओनली ऑन टू द अलोकेटेड सेल। सो अपने पास दो ऑप्शन है, इधर आई कैन जंप हियर और वी कैन जंप हियर, ऑप्शन नंबर 2। सो सी, अगर मैं ऑप्शन नंबर 1 के साथ गया, आई जंप ऑन टू दिस सेल। नाउ आई नीड टू टर्न इधर वर्टिकल, अप और डाउन। बट सी, यहाँ पे भी कुछ ऑप्शंस अवेलेबल नहीं है। जंप कहाँ पे करेंगे? यहाँ पे भी कुछ ऑप्शन नहीं जंप करने के लिए। सो दैट मीन्स दिस ऑप्शन इज रॉन्ग। अगेन वी विल चेक आउट द सेकंड ऑप्शन। चलो यहाँ से इधर जंप मारा, फिर टर्न किया, जंप मारा, फिर टर्न किया, जंप मारा, देन अगेन वी टर्न, jump onto the allocated cell, again turn and jump, then again turn and jump. Yes, up to this part no problem, but now we need to turn. So if we turn on this side, no allocation. If we turn on this side, no allocation. So that means a closed loop हम यहाँ तक ही reach हो गए। देखो, our aim was to reach up to this location, but no loop has been formed here. So this cell, the current cell, is called as a independent cell. This is your independent cell. So that's why we are going to allocate epsilon in this location, because it's a minimum cost with independent cell. I hope now it is clear to you. Is it clear now? Gaurav?
Yes, sir.
Okay.
Yes, sir.
Hello? Is it okay? Should I go? Should I proceed?
Yes, sir.
Okay. So let's see the UV method, because we have spent only one lecture on the UV or modified distribution method. So I'll repeat the process again, those who were absent in the previous lecture. So in UV method, what you do, you assign U values to each row, that is U1, U2, U3, U4, and V values to each column. Okay, so V1, V2, V3, V4 and V5. Now अब देखो, अपने पास जो अपना मैट्रिक्स है ना, ये यहाँ पे दो केसेस अवेलेबल है. There are some cells who are occupied or allocated, and there are some cells those are unoccupied or unallocated. Okay, दो भाई है, एक allocated है, एक unallocated है. Now what is the aim of this optimization? कि भाई हमने गलती से एक ऐसे सेल में अलोकेशन किया है जहां पे करने से वी विल हैव द मैक्सिमम कॉस्ट. इफ वी अलोकेट ऑन टू द अनअलोकेटेड, जो ब्लैंक वाले सेल है, अगर वहां पे हमने कुछ कंपोनेंट, नंबर ऑफ कंपोनेंट ट्रांसफर किए होते, वी कुड हैव गॉट द मिनिमम ट्रांसपोर्टेशन कॉस्ट. ठीक है, सो दैट्स मीन some of the unallocated cell should be occupied, allocated, and some of the allocated should go out, they become unoccupied. Okay, ऐसा कुछ चेक करना है. कैसे चेक करेंगे? नाउ by using UV method. At allocated cell और occupied cell एक फॉर्मूला है, देखो, पेनल्टी इक्वल टू और कॉस्ट इक्वल टू U प्लस V वैल्यू. सो दैट इज UI प्लस VJ वैल्यू. सिंपल है. मतलब अगर सी, दिस इज योर ऑक्युपाइड सेल, so this unit cost 6 is equal to U plus V. So that is 6 equal to U1 plus V1. That's it. ये अपना फॉर्मूला है. This formula is applicable for occupied cell. ठीक है। और अनऑक्यूपाइड सेल का लिए फॉर्मूला अलग है। अनऑक्यूपाइड सेल का जो फॉर्मूला है, पेनल्टी एट दैट सेल, because that is unallocated, penalty is equal to cost, कितना कॉस्ट है उधर, फॉर एग्जांपल यहाँ पे 4 है, so that will be CIJ minus addition of U and V value, UI plus VJ. Now see, for allocated sale, CIJ will be equal to UI plus VJ. ठीक है। पेनल्टी क्या है, इन दोनों का डिफरेंस इज द पेनल्टी, but you calculate the penalty for unoccupied and you calculate penalty for unoccupied, ठीक है। so ये तो फॉर्मूला theoretically मैंने एक्सप्लेन किया। let's do actual calculation. Now first thing, our aim here is to calculate all the values of u and v values v, so have the first initial guess or start point। क्या करो, कोई भी एक u वैल्यू और एक v वैल्यू एज्यूम करो इक्वल टू 0, कोई भी चलता है, नो प्रॉब्लम, बट आई हैव अ हैबिट, आई स्टार्ट विथ u1 इक्वल टू 0, यू कैन टेक एनी वैल्यू, ठीक है। सो व्हाट आई डू, आई एज्यूम u1 इक्वल टू 0, ओके। अब मैं क्या करता हूं, फ्रॉम दिस पॉइंट we will calculate all remaining values, that is u1 sorry u2 u3 u4 v1 v2 v3 v4 v5 सब कैलकुलेट करेंगे by assuming u1 equal to 0। let's start calculation। so see, 6 here, this 6 is equal to u1 plus v1 okay, but here u1 is equal to 0 हमने assume किया, so v1 will become 6 now, right? So this way you do the calculation, so अपना v1 becomes 6, एक मिनट, v1 become 6। so similarly go for the next calculation, देखो u1 0 है, v1 6 है। now for next calculation I'll jump onto the allocated cell here, 1 equal to u1 plus v4, u1 is equal to 0, so v4 becomes 1, okay। similarly proceed like this, follow the same steps, 3 allocated cell is 3, so 3 equal to 1 plus u2, 1 plus u2, so u2 becomes 3 minus 1, that is 2। similarly do the calculations। अब देखो यहाँ पे देखो डमी सेल कितना है 0, u2 is 2, so v5 कितना होगा, सी 0 equal to u2 plus v5, but u2 is equal to 2, so v5 will become minus 2, ओके। सिंपल कैलकुलेशन है, आप इजीली कर सकते हो ये। सो डू दिस कैलकुलेशंस लाइक दिस, v5 becomes minus 2। नेक्स्ट वन, अब देखो यहाँ पे जंप मारते, 0 equal to minus 2 plus how much becomes 0, so it should be plus 2, so u3 should be 2। नेक्स्ट u3 अगर 2 है, how much will be v3, 0 plus sorry 0 equal to 2 plus v3, that is minus 2, so v3 should be minus 2। नेक्स्ट आगे का वाला और कैलकुलेशन कर सकते हैं कुछ, ओके। v1 is 6, so 7 equal to u4 plus v1, so v1 is 6, so u4 will be 1। देन V2 कैलकुलेट करेंगे, V2, so for that 1 equal to U4 plus V2. U4 is equal to 1, so V2 should be equal to 0. So by this process you will do the calculation and calculate all the values of U and V. Now we are going to calculate penalty for each unoccupied cell by these values of U and V. Okay, again penalty calculations is simple. For example, we are going to calculate improvement index or penalty for P2 point. So this location, this is unoccupied cell. So location or penalty for row number 2 column number 1 is equal to cost कितना है वहां पे 20 माइनस u plus v. ओके u कितना है 2 plus v कितना है 6, so 2 plus 6 8. So that will be the penalty at this location, which is equal to 12. Now as this is a positive number, that means if we do the allocation at this sale, we are going to increase the cost, increase the transportation cost. So that's why avoid doing that. So I'll say here no gain, no gain in here. Whenever you get a penalty as a negative number, some negative value, that means there is a gain. We can further decrease the transportation cost. So seek the penalty with negative number. If you hit the positive number, skip it. आगे चलो. So let's do the calculation for next value. Okay, so P21 is 12. Now for this one I'll do P row number 3 column number 1. The cost is 7 minus U plus V. U कितना है इसको 2, V कितना है 6, so 8. So that means P31 penalty is equal to -1. Okay, so there could be a gain here. Let's do the calculation for next unoccupied cell. Penalty for row number 1 column number 2. Okay, the cost is 4 minus u plus v. U is 0, v is 0, so minus 0. So penalty is equal to positive 4. Next calculation, penalty for row number 2 column number 2. The cost is 6 minus u plus v. U कितना है 2 plus v कितना है 0. So 6 minus 2 4. No gain. Next one, penalty for row number 3 column number 2 is equal to cost कितना है 1 minus u plus v. U कितना है देखो 2 plus v कितना है 0. So we will put here 2 plus 0, that will be 2. So penalty -1. So there will be a gain here -1. Next calculation, next cell लेते ये वाला penalty for row number 1 column number 3. The cost is 9 minus u plus v. U कितना है 0 plus v कितना है -2, so -2. So 9 minus -2 becomes 11. So no gain. So I hope all of you have understood the concept. Do the calculation for all unoccupied cell. You will find that only for P31 and P32 you get the gain. यहाँ पे allocation करना चाहिए हमने. So select cell with the least cost and prepare a closed loop for optimization. Okay, so if you look at P31 cell, P31 or 3, 1, row number 3 column number 1, the cost is 7. नेक्स्ट कहां पे allocation करने से अपना gain होने वाला है P32 row number 3 column number 2, so that means this. So second opportunity is at location 3, 2 where the cost is 1 only. अब देखो अपना कॉमन सेंस यूज करो. 7 रुपीज में अलोकेशन करोगे या फिर 1 रुपीज में अलोकेशन करोगे. it should be least cost, right? So जहां पे minimum कर सकते हैं, select that one. So in this problem we are going to select or do the allocation here at this location. So कितना allocation करना है, कैसे allocate करना है, for that you need to prepare a closed loop. तो यहाँ पे एक closed loop बनाएंगे. So closed loop बनाने के लिए we have option like this. We can jump onto this part and come back. So your closed loop will be something like this. Okay, so I'll clearly draw it again from 1 to 1, then turn and jump onto the occupied, then turn and jump, again turn onto the right hand side but jump onto occupied cell, jump किया, then turn, turn, turn and come back. So this will be your closed loop. So prepare the closed loop. Now next task is to assign the sign, पॉजिटिव निगेटिव, जस्ट अल्टरनेट करके जाना है. जस्ट रिमेंबर जहां से आपने जंप मारना स्टार्ट किया, द स्टार्टिंग पॉइंट शुड बी अ पॉजिटिव बिकॉज वी आर गोइंग टू डू और वी आर गोइंग टू add a location at that location. So that's why starting point should be having positive sign. Okay, so let's add a positive sign here. So here it will be plus, then next alternate करते जाओ, minus, plus, minus, plus, minus, plus, minus and come back. Okay, so this will be your sign. Now next, अब आपको क्या करना है, allocation transfer करने. So from one occupied cell to this unoccupied cell you need to do allocation. Okay, कितना allocation करना है यहाँ पे, with the minimum value at the negative cell. Look for the negative cells. ये एक सेल है, सेकंड सेल, थर्ड सेल and fourth cell. Now look for the allocation number or values of allocation. Here it is 30, 30, 20 and epsilon. So select the least value of allocated resources. ठीक है, कौन सा सबसे कम है, epsilon, because हमने पता है कि epsilon is almost equal to 0. Okay, so what you need to do, जो least number है, here it is epsilon, might in some cases it might be 10 or 20 or something. Okay, so if you get some number, क्या करना है, जो निगेटिव सेल है उसमें से उसको कम करो एंड जो पॉजिटिव सेल में उसमें वो ऐड कर दो. Okay, so what we are going to do, this negative epsilon, epsilon से कम कर दिया, ऐड कर दिया इधर, ऐड कर दो जहां पे भी पॉजिटिव है, 60 प्लस इप्सिलॉन, 10 प्लस इप्सिलॉन, 20 प्लस इप्सिलॉन. Okay, then subtract epsilon from negative cells. So 20 minus epsilon, 30 minus epsilon and 30 minus epsilon. But we know epsilon is a kind of a zero only, so you can neglect this. So finally you will get resultant or the final optimized way like this. सिर्फ क्या हुआ है, इधर का epsilon went with this location, new location, that's it. But if you do the calculation for transportation cost, it will remain same 700. Okay, but based on the method, now all the cell, unoccupied cell will have a positive penalty. ठीक है, अगर आपने calculation किया, again you need to do the calculation for v1 sorry u1 v1 v2 v3 v4 v5, क्योंकि सब सेल चेंज हो गए, ऑक्यूपाइड सेल चेंज हो गए. सो redo the calculation, and if you do the calculation for penalties for unoccupied cell like P row number 2 column number 1, so cost is 20 minus U plus V, U is 2 and V is 6, so it will be 12 and so on. So like this way, if you do the calculation for all penalties will be positive. So as soon as you get all penalties positive, that means you reach the optimal solution. This will be your answer, final answer. You need to stop it here. Okay, so any doubt in the transportation problem or transportation model, you can ask. In the next lecture, we are going to start assignment model.